Hello, Jack Jackson back again. In this section, we're going to talk about continuous CDFs, and we're going to use the formula of a CDF to find inverse probability or answer inverse probability questions using a graphing calculator. We're going to use this on a TI-84 and a TI-nspire. So here's a formula that I actually used in the last video. Here's the CDF is 1 over 1 plus 2 e to the negative 0.3x. Suppose we have these kinds of problems. The probability of x is less than a equals 0.4, find a. Let's just do that problem first. Okay, so what we're looking at is, first of all, get the formula in your calculator. And here it is on the TI-84. Let me just actually pull up a TI-84. I think I already have this one in. So there it is, 1 divided by 1 plus 2 e to the power negative 0.03x, close. All right, so there's the formula. It's in there. Now we might want to graph this, and we need to experiment to find a window. Now we don't have to experiment for the y's. It's a CDF, so we know if we go essentially from 0 to 1, this is going to work. So I'm going to do 0.2 to 1.1. And it turns out that negative 20 to 25, as we saw in our last video, works out to be a pretty decent graph. So there's a graph of it. What should we see if it's a CDF? We should see it at 0 or approaching 0 on the left, and either at y equals 1 or approaching y equals 1 on the right. In between it should be continuous, one connected piece, and increasing. So basically when I say the probability of x is less than a equals 0.4, and I want to find a, I'm saying the CDF equals 0.4, and I want to find a. So in other words, I know the y value on this curve is 0.4, and I want to find the probability. Now we can use trace to give it an x value like 3, and it'll come up with the y value right away. That's pretty easy, but how do we go backwards? How do we take a y value and find an x? So the calculator doesn't allow us to do that directly, but we can indirectly get there pretty easily. And so what we could do is we can actually graph a horizontal line at the y value we want. And so that is, you just plug in the y value you want. Now this y value needs to correspond to a probability to the left, which is what we have here, and then that's an actual y value on the curve. So if we graph that, now we see that that's the y value we want, and we want to find the corresponding x. We're just finding the place where they cross. And luckily the calculator does that very well. We just do second trace, which is calc, and we choose number 5, which is intersect, so I can either arrow down and hit enter, or I could just press 5. Now, the calculator could have up to 10 different graphs going at once, and it has to have only 2 graphs for this process, so it's going to ask us which curves. So it up and down switches between curves, left or right switches within the curve. So have your curve on the CDF curve first, hit enter, go to the horizontal line, hit enter, then it asks us for a guess. Use your arrow keys to get it as close as you can get to where it looks like they cross, and then hit enter. And it's going to come back with the y value of 0.4 that we knew, and it's going to come back with the corresponding x value right there. Notice if I quit and I type in y, it's going to give me the y that we were just at, and if I type in x, it's going to give me that x value. Sometimes this will show you a couple more digits, but we're probably going to not need this many digits anyway. So that gives you how you can do it. So basically, you're always going to want to do it that way. Now, on the nspire, we have actually a couple of ways we can do this. One way is, let's pull this up here. So I have my formula in as F1. So couple ways you can get that formula. There are a couple ways you can get that formula in. Let me show you one way I can do it. One way I can go to the graphing window, which is over here in 1.3. I can do Control G hides or shows the place where we put in functions. And so we put that in there and we type in our formula right there. And we can graph it. Now we can also do this exactly like the last one. We can do Control G, put in our cumulative probability, which is 0.4, which will graph a horizontal line. Then we can go to calculate the intersection by going Menu, Analyze Graph, and Intersection. It's going to ask us for a left bound, so go to the left side, a right bound, and that's, you don't have to seed it with a guess, it actually figures it out. So it gives you the value. Unfortunately, it doesn't give you very many decimal points, but decimal values, but it does compute it that way. But actually on the TI-nspire, we have an actually even better way of doing it. We can actually, once we've got our formula in F1 of x, and we can actually type something in, you know, like if I want to change the value to 0.5, I can actually say store it in, say, F2 of x, like that, and it actually stores that constant function in F2. So it changed whatever I had in there earlier. So I can actually type the formula in and store it right from the home screen. But once I have my CDF in F1, okay, then I can go ahead and do this calculation, because I can go to Menu and this will actually solve equations for me. So I go to Algebra and choose number 1, Solve, and I can solve F1 of x, and I want it to actually equal, in this case it was 0.4, and then I say comma, solve it for the variable x. And that's the syntax you use, and bada bing, there it is. So you can actually solve these directly from the home screen, which is probably the more efficient way of doing this on the nspire. So many of you have a TI-84. What you want to do is just graph a horizontal line at the cumulative probability, the probability to the left, and then which in this case is 0.4. Then you'll see the graph, look where they cross, do a calc intersect, and you're good. You can use the same technique on nspire, or probably better and easier is just solve the thing from the home screen. All right, the next one says the probability that x is greater than b is 0.05. Probability x greater than b is 0.05. Do you know how to solve that one? Well, notice that probability of x greater than b is 0.05 is a right probability. So if the probability of x is greater than b is 0.05, the probability to the left is 1 minus that, which is 0.95. So the CDF has to be 0.95. So 0.95 is the value you put in and do a calc intersect on the calculator. Let's go ahead and just for practice, let's go ahead and let you see that again. So you go to here, put in 0.95, and then do a calc intersection, number 5. It's going to graph it. It may take just a second to do this, but it's going to graph the CDF again, and then the horizontal line at 0.95. Identify our 2 curves. If you only have 2 curves, it's pretty easy. Enter will do it. And now I can actually type in a number here that's my guess, or I can use the cursor to get over. That looks like that's in the ballpark of where it's crossing. Hit enter, and it gives you an x value there, which is what I've copied down here. On the, you can do a similar thing here on the nspire, or in the nspire again, probably the easier thing to do is to just do it like this. So you go to Menu, Algebra, Solve, and we get F1 from here. F1 of x equals, and again it's 0.95, and when I solve that for x, got a parentheses problem here. Get out of that parentheses first. That looks better. Now hit enter. Boom, there it is. So there's the value that we need, 12.125 something. Okay, the next one is to find the median. What's the median of this distribution? Well, the median is an x value so that the probability to the left is 0.5. In other words, it's the x value which has the CDF of the median is 0.5. So it's the same thing on the calculator here on the TI-84. You just go back and change this to be 0.5 for the left probability and do a calc intersect. Again, we got to wait for it to graph. Once it does, it's going to ask us for our two curves. Hit enter, enter, and we're pretty close to where it crosses now, so enter, and there's the x value we're looking for. On the Inspire, the way I would probably do it is use solve. So again, that was menu, algebra, number 1. Or you can actually just type in solve, open parentheses, it will work too. So we can solve f1 of x, get out of the parentheses, equals 0.5, solve that for x, and that is the median. So that x value is the median there. All right, how about finding the 60th percentile? Okay, if we want to find the 60th percentile, then it's the same thing. We just want this to be 0.60 or 0.6. And again, we just want to do a calc intersect here, and that will take care of it. Or in the Inspire, again, it's a solve. It's just a 0.6 here instead of 0.5. And so this x value is the 60th percentile. The probability to the left is 60%, 0.6. All right, here's some exercises for you to do. Here are 4 exercises. We'll do them one at a time. But here's a new formula here. Now notice that the only part that really matters is between 5 and 10. So instead of putting this in as a piecewise defined function, you can actually just put in the part from 5 to 10 as y1. Just make sure you're not using it outside the interval 5 to 10. Don't graph it outside that window. Don't do any calculations with it outside that window. So the first one is the probability that x is less than a is 0.1. What's a? See if you can figure that one out. Press pause. Come back when you got it figured out. Well, put in the formula here for y1. Choose y2 as 0.1. Choose the appropriate window. This is only from 5 to 10 because that's the only place this applies. And then, of course, our standard window for the y is negative 0.2 to 1.1. Do a calc, intersect, and then, first curve, second curve, trace, or first curve, second curve, put the arrow to the guess, and then there it comes up, and there's our x value that we want. So there's a probability to the left of 0.1. You can do it with solve on the Inspire, but when you solve it, it comes up with 2 things. Well, it's basically taking this horizontal line, and this curve, if it were to continue on, is going to come back up over here and cross again at 3.4. That's outside of this range here, so it's going to be throw out that solution. The only one that makes sense in this region is this 6.58 thing. So that's it. Okay, see if you can do one where the probability that x is greater than a is 0.1. What's a? Come back when you think you have it. Press pause now. Well, if the probability to the right is 0.1, then the probability to the left is 0.9. So you do the same thing, but you change this to 0.9, graph that one, and do a calc intersect, and you get about 9.74. On the Inspire, you still use solve f1 of x equals 0.9 for x. And this 0.25 again is outside this interval, so that one's thrown out. The one that is in the interval from 5 to 10 is the one that makes sense, the 9.7434. All right, compute the median of this distribution. Come back when you think you have an answer. Press pause now. Well, it's the same thing. The difference is you just changed this to 0.5. So the median or percentiles are actually inverse probability calculations. And again, what are they? How do you do that? You put the CDF formula in Y1, you put the cumulative probability, that is the probability to the left, the less than probability, in Y2, and then you just calculate the intersection. And that will give you at least approximately the value that you need, for in this case the median. So the probability that x is less than the median is 0.5. On the Inspire, probably the easiest thing is to use solve. So solve f1 of x equals 0.5 comma x. And again, this 1.46 doesn't make any sense in the context, so that it's the one that makes sense is the 8.5355. All right, one more, the 60th percentile. Come back when you got that one figured out. All right, well, you're back. I hope that means you've worked this out. So it's important that you try some of these on your own. You should have known that 60 percentile means there's 60% probability to the left. So you just change that to 0.6, graph that, and we get that to work out. And there we go. Or do the solve over here. Again, this one has a solution we throw out. We keep this one here. Now, in some cases, we have a special situation where we have a symmetric distribution. In this case, the PDF graph is symmetric about the mean, and the C that has a reflective symmetry about the mean. And the CDF graph has point symmetry about the point mean comma 0.5, and then the mean will equal the median. Okay, so the PDF graph has reflective symmetry about the line x equals the mean. The CDF graph has point symmetry or rotational symmetry about the point mean 0.5, and the mean equals the median. If we have a symmetric distribution, then we can find a special kind of inverse probability centered on the mean. So we're looking for x between the mean minus k and mean plus k. So we're going to go k units above and below the mean and look for the probability between there. And say we know that that's some value p. Well, because it's symmetric, this probability here is the probability that it's not p is in the two tails. This is a middle probability. So the probability to the left of mu minus k and the probability to the right of mu minus k, of mu plus k, if you add those up, you get 1 minus p. But it turns out that these two guys are the same thing because of the symmetry. So twice this, say either one of these, say twice this mu x less than mu minus k is equal to 1 minus p. So what we could do is we know that the probability that x is less than mu minus k is 1 minus p over 2. Or the probability that x is greater than mu plus k is also 1 minus p over 2. So the probability that x is less than mu plus k is 1 minus p over 2. So basically, let's look at a picture here. So here's an example of one that's symmetric. Here's a formula for the CDF. 1 over 1 plus e to the negative 0.7x. If you graph that, it has a horizontal asymptote of y equals 0 on the left, y equals 1 on the right. It's one continuous increasing piece, so we know that is a legitimate CDF. Its corresponding PDF is given by this blue graph. Okay? Now, if you know calculus, what I did is I just took the derivative of this to get the blue one here. Okay, but regardless of what the formula is, that's what it looks like. And so notice that the mean is actually 0, and which is also the median. And actually, it's also the mode here because it's the highest point on the graph. And so the mean, median, and mode are all the same. It's a mound-shaped PDF. And so what we see here is the probability to the left of this is 1/2. Half the area is here, half the area is here. So that means the y value here at x equals 0 is 0.5. And so what we have here is a vertical line of symmetry at x equals the mean, at x equals 0, the y-axis, is a vertical symmetry on the blue graph. And this point, 0, 0.5, is a rotational symmetry point for the red graph. If you rotate it 180 degrees around that point, this part here would rotate down on top of this, and this part would rotate back up on top of that. So this is what we mean by a symmetric distribution. Now what we're looking for in this case is basically this situation here, and so we want to find these values L and U so that they're the same distance from the mean, and this area under the curve between these two under the PDF is the area we're looking for of 0.8. Or in other words, this vertical distance on the CDF graph from here down to this one here, so take this y value, subtract it from this y value up here, that gives you this orange distance. We want that to be 0.8. Well, if that's 0.8, then the part that's out on the outside tails is 0.2, and because of the symmetry, we know that's 0.1 in each tail. So 0.1 is over here, 0.1 is here. So the amount of probability that's below this L is 0.1. The amount that's below the U is 1 minus that, which is 0.9. So we could just do an inverse probability for 0.1 to get L, or an inverse probability of 0.9 to get U. So the way we can do that is, since we have our graph of our CDF, we put that in, that formula in, our Y1, we put in 0.1. This gives us a horizontal line right here crossing our CDF. Calculate that intersection, and there's your X value that we're looking for, the lower. And because it's symmetric about the mean was 0, it's the same distance up. However far that is below the mean, we go that same distance above the mean to find our other point. Since the mean is 0, it's just the opposite sign. Or we could do it this way. We could solve the CDF F1 of X. I put that in as F1 first before I did this. Here you can see it on the graph, and did it that way on the graph. Calculated the same way to get the same value with the calc intersection. Or I can do it from the home screen by solving the CDF of X, which is F1 of X, equals 0.1 for X. That gives us the lower. And then I did the F1 of X equals 0.9, solve that for X, and that gives us the upper. And of course, because of the symmetry about 0, these are just opposites of each other. All right, one more final piece, and that is this. How do I get a graph of something like this on a TI-84? Okay, and we can do it. It's a little bit tricky. And what you do is this. You put the first formula 0 in, and then I put the condition in parentheses, x minus x less than 2, plus then the second formula in parentheses, and then the condition in parentheses, x 2 is less than or equal to x, and then also in parentheses, x is less than or equal to 4. Plus the last formula 1, and then in parentheses the condition x greater than 4. Now let me show you how to do that actually on the calculator. And then let me explain why it works, and then let me put it in the calculator. So why it works is this. On the TI-84, when you get an expression like x less than 2, that's going to be a statement that's either true or false for any particular value of x. And the way that TI-84 works is if that statement is true, you get a 1. If it's false, it gets a 0. So let's look what happens when x is less than 2. The x less than 2 is 1. The x greater than or equal to is 0, so this part is 0 because it's being multiplied by 0. And x greater than 4 is false, so that part is 0. So here you have 2 zeros added in. This is 1. What's left? That formula, which is 0. If the number x is between 2 and 4, the x less than 2 is false, so that part's 0. The x greater than 4 is false, so that's part 0. And both of these parts, x2 less than or equal to x, and x less than or equal to 4 are both true, so they're just 1s, and we're left with this formula in the middle with the appropriate value of x plugged in there. And if x is greater than 4, one of these is 0, this one right here, and that one's 0. So, and this one's 1, so this works out. So it's a little bit tricky here, but it can be done. And so let me show this to you. And so let me put it in. So parentheses, 0, parentheses, parentheses, x. Now, what about the less than? They're under test, which is second math. And number 5 is less than 2, close parentheses, plus Now the second part of the formula, 1/4 times x minus 2 squared. Close that parentheses. And then that's times the two conditions. 2 test less than or equal to is 6. Less than or equal to x, close parentheses, open parentheses. X less than or equal to 4. Test again. 6. Close. Plus, in parentheses 1, close parentheses, parentheses open again, x greater than 4. Under test number 3, greater than, and then 4. And what this should do, if we did this right, it will produce a table that works correctly. Notice for the x's less than 2, we get zeros. At 2, it's also 0. And then we get 3 there, it's something else, and then from 4 on, we get 1s. But of course, the only part that's really interesting is the part starting at 2 and going up to 4. So let's maybe go up by tenths now in our table. And now we see, of course, it's 0 out here. But the interesting part is what happens to these guys in here. And of course, they work their way up to 1. And so when you graph it, let's get a window. Let's go a little less than 2. Let's actually just start at 0 and let's go a little past 4. Let's go to 6 and use our standard. Let's go mark it off by 1s and our standard window for y's. And this will graph it here. Let me go back here, and I can actually make this thicker so we can see a little bit better. Let's make that thicker by pushing enter on that thing. Hit graph. And now you can see it tracing over the x-axis. Here goes up, and then it's horizontal. So you can actually get it to do a full PDF if you need to. Now, that's one way to do it. But of course, the easier way to do it is to just ignore the stuff where it's x is 0 or x is 1, and just don't worry about the actual piecewise defined function. Let me turn it off. And all you need to do is graph, well, let me turn it back on for just a second. You just need to graph the part in the middle that's the important part. 1/4 x minus 2 squared. Now, if I graph this, it's not going to be correct for the whole thing because it's going to see this part of the graph's not correct, this part up here is not correct. But if we restrict our attention to only graphing x's between 2 and 4, which is where that middle part works, and look at the graph, the two graphs are exactly the same. The second graph is just going to graph on top of it. So in fact, I don't really need this one here at all. I can just graph this one here as long as I only look at the part between between 2 and 4 and ignore anything else. So I'm only using this formula. I only do anything with this in that interval. Then everything is good to go. Now, the way you can actually get this piecewise defined functions as true piecewise defined functions on the TI-nspire, it works a little bit better. So let's see. Here's my formula up here. Let me just clear out a few things. Okay, start with a blank screen here. Now, there's my formula. I can actually basically enter it in like this. So the way you do that is where you get a lot of stuff on the nspire is this little button right here. And it's this one, actually the one I've got highlighted. You click on that. I need a function in 3 pieces. So I click OK. And I type in my formula there. And I basically type it just like it looks. The formula is 0. And then I put my condition here, x, and less thans or greater thans are the control equal. Control equal less than, was it It's 2, yeah, 2. And the last piece is pretty easy too. It's 1, and that's for x's control equal greater than 4. And for the middle pieces, we want 2, and it understands this just fine to type it just like this. Less than or equal to x, less than or equal to 4. And then type in the formula here, which is 1/4 x minus 2 squared. Uh, 1/4. And then parentheses x minus 2 and then square. And in fact, what if I want to graph that or whatever? I could put that in a graphing by saying store, control variables, and then store it in, if I type in F1 or F2, I could say F1 of x, for example, and it'll just say done. But now if I go over here to my graphing window, there's the graph. And it looks like I've got a horizontal thing there with it for calculating a cumulative probability. So that's the median of this particular one. 3.41 is the median because the cumulative probability is 0.5. Isn't that cool? So it actually enters it in actually like we would write it in mathematics. All right, so this section we've looked at the going from continuous to continuous from discrete, making that transition, and in particular we've been looking at how we can use a CDF graph, a CDF formula, our calculator to compute probabilities and now inverse probabilities, and so we should be in pretty good shape with that. And the next step is for us to look at how to use a PDF.